traveling at or faster than the speed of sound. We use the term Mach 1 for traveling at the speed of sound, 340 meters per second, or it's about 750 miles per hour. Right? My animation here shows the object that's emitting the sound source, but he's moving along with the sound waves. And you can see all the sound waves are just building up right in this line as the object moves along with it. And what happens here, if I'm at this point right here, the object is actually going past me, and it has passed me by the time the sound waves actually get to me. And there's a whole bunch of sound waves that all hit me at once. That's what creates a sonic boom, is all of these sound waves hitting you at the same time. Here's a picture of a jet aircraft traveling around the speed of sound, and you can see all of these pressure waves building up behind it. I also have a video clip of the plane flying past here. Unfortunately, it doesn't have sound, but you can see that cone building up behind the plane there. And let me pause it and back up so we can. So this is the whole area where all those sound waves are building up past the plane, and it's not till the plane gets out here past where you are before these waves actually hit you. A sonic boom sounds like a thunder or the crack of a whip as those waves build up and pass you. All right, objects going faster than the speed of sound are called supersonic. This diagram is showing something going 1.4 times faster than the speed of sound. We call it Mach 1.4. And again, you can see all these waves building up behind the aircraft there. So if I'm here, all of those waves hit me all at one time, and that makes my sonic boom right there when they hit me. A bullet coming out of a gun actually travels 2.40 times faster than the speed of sound, 2.45. We call that Mach 2.45. And this is actually a picture that's captured of a bullet flying, and we can see some actually lines build up behind it, and we can see some air turbulence behind it as well. Fast objects, the fastest car ever recorded on the surface of the Earth is 431 meters per second. That's faster than the speed of sound, so he created a sonic boom behind it. Somehow that looks more like a rocket than a car to me, but that's what they tell us. We have jet-powered aircrafts that travel faster than the speed of sound. This one goes Mach 3.3, so it's 3.3 times faster than the speed of sound. Now a jet, inside a jet, they have air turbines inside of here, and they're sucking air in this side and pushing the air out the back. So it's just like big fan blades in there that propel the jet forwards. The next fastest set of aircraft that we have are rocket-powered aircrafts that's actually shooting an exhaust out the back. And this one goes twice as fast as that other jet. It goes 6.72 times faster than the speed of sound. This is the fastest aircraft that we have. This is a top-secret NASA aircraft. The only thing they've released about it is the name of it, this picture, and this speed, almost 10 times faster than the speed of sound. It's a top secret thing, and nobody knows anything else about it. And I've been looking for several years now. I keep looking it up every year, Googling it, see if there's more information, and this is all I've ever been able to find on it. Notice the new name hypersonic is given to things going between Mach 5 and Mach 10. All right, things that go faster than that, rocket ships, in order to get away from Earth's gravity, a rocket ship has to get up to a speed of 32.9 times faster than the speed of sound. And they also do that by a lot of times they do a circular motion around the Earth to help get up to that speed. Speeding up to this incredibly fast speed creates a lot of stress on the astronauts. That's the G-forces that they're always talking about. They get up to like 8 or 9 Gs, which if you're not trained properly could kill somebody or definitely make you black out. When the astronauts were landing, coming back from the moon, they actually got up faster than that, 36 times faster than the speed of sound. This is the actual space pod that came back from the moon from the Apollo mission. They have it on display at the Smithsonian Institute in Washington, D.C. And you can see this is all burn marks on the pod here. You're going 36 times faster than the speed of sound, and you start going through the atmosphere, there's an incredible amount of friction, and it gets really hot. And they have to cover these things with special heat tiles so that they don't burn up and melt the space pod. We've made some spacecrafts that do not have astronauts in them that go faster than that. In the 1970s, the Voyager series got up to 50 times the speed of sound. And we have some rocket boosters to get them off of the Earth's gravity up to Mach 32. And then to get going faster than that, they used some kind of smart tricks. What we did was shoot the spacecraft towards the larger planets like Jupiter, which is much more massive than the Earth and has a lot more gravity than the Earth. And as that rocket ship got closer and closer to Jupiter, its gravity pulled it and made it go faster and faster and faster. And then once it passed Jupiter, we got it to go towards Saturn, and we did the same thing. Saturn is also very massive, has a lot more mass than the Earth, a lot more gravity, and pulled on that ship and made it go even faster as it flung past Saturn. So this animation is showing the two paths of a couple of the Voyager probes that we've sent out in the 1970s and 80s. Now we've also made one spacecraft that went actually faster than this, and in order to do that we need an object that has more mass and more gravity than Jupiter, and that of course would be the Sun. We sent this spaceship out appropriately named Helios, going towards the Sun in 1976, and it got going almost 200 times the speed of sound, because the Sun's gravity, of course, is 99 times bigger than Jupiter's gravity, and got it going that much faster. Oh, and let me point out, the speed of light is Mach 1,000,000. It's 1,000,000 times faster than the speed of sound. And looking at our examples here, there's no way we can make a spacecraft that can get anywhere near this. Using the huge gravity of the Sun, we've only been able to accelerate something up to 200 times the speed of sound, nowhere close to 1,000,000. All right, pause, and this will be our last copy.